Hello everyone! So hopefully you've watched the video about Lewis dot structures and more detail about those, and now we're going to use the Lewis dot structures that we made to figure out the shapes and angles of the molecule. These shapes are always going to be around a central atom, so generally that will be really obvious. If ever it's in a molecule that has more than one possible central atom, I'll always let you know. So let's look at a few examples. So the shapes that we're talking about are the VSEPR shapes. VSEPR stands for valence shell electron pair repulsion theory. So basically it just says that electrons will try to get as far away as possible from each other because they repel. So if you aren't sure what that is, you should probably review that. There's some in your textbook, or you can look it up online or in your Gen Chem book. But basically, what we're going to do is use tables to figure out what we have. The first thing we need to know to use the table is what an electron domain is. So an electron domain is defined as just where electrons are. So basically it's like a little code. So in this molecule, example 1, these are the examples we had from before. In example 1, if you look at the central atom, because that's going to determine the shape, how many electron domains are there? An electron domain could be a single bond, a double bond, a triple bond, or a lone pair. It could be any of those things. It could actually also be a radical, but we're not there yet, so we're not going to have any of those. So now knowing that, all we have to do is look at the central atom and count the electron domains around it, and then we can figure out what the shape is. So let's do that now. For example 1, we're looking at the N. So as you can see, we have 3 single bonds and 1 lone pair. So that'd be 3 plus 1, so that number of electron domains would be 4. For the second example, we have 2 single bonds and 1 double bond. So that would be 2 plus 1. Remember, the double bond only counts as 1 electron domain, even though there's more than 2 electrons there. And that's because a double bond is actually only one place where there are electrons. The way that it works is there's a bond in the center, and then there's electrons around that bond, and we'll talk a little bit about that when we talk about hybridization. But they're actually in the same spot according to the molecule and the way the shape would look. So that counts as 1. So 2 plus 1 is 3, so that would be 3 electron domains. For example 3, we've got H3O plus. If you look here, we've got 3 bonds plus a lone pair. That's 4 electron domains again. So based on all that, how many electron domains would there be for example 6? Pause the video if you need to try to figure it out. All right, hopefully you said 4 because there's 3 single bonds plus 1 double bond. That equals 3 plus 1, which is 4. So there's 4 electron domains. Just for fun, let's try to do one more example. So looking at example 7, what would be the number of electron domains around the central atom? Again, pause the video if you need to. All right, so hopefully everyone realized C is the central atom, right? And got the electron domains is equal to 2. Because again, double bonds are only count as 1 electron domain. So to use this to actually figure out what the shape is, we're actually going to need a little bit more information. So here's the information that you're going to need to know. Now, I've made this table because it makes it nice and organized, but you're going to have to memorize the names of these different things and the angles as well. Just know that for most of this class, we're going to ignore rows 5 and 6. So really, that cuts in half the number of things you have to memorize. And the reason is because most of the things we're going to deal with are organic, which means they have carbon, and carbon, we said, can't have more than an octet. So there's no way it could have more than 4 bonds around it, right? So it couldn't be 5 here where it's trigonal bipyramidal, because I would have to have 5 things around the center, and carbon can't do that. So I'm basically knocking off half these things that you have to memorize. So looking at this table, E is the central atom, and then X would just be any atoms around it. The lone pairs are shown by dots, but they're like lines attached to the dots. So if you look at the one that says trigonal planar, it's got E, central atom, and then 3 bonds around it. But if you look at, say, trigonal pyramidal, which normally has an AL there, that has 3 bonds, so those wedges and dashes are just bonds, and then 1 lone pair. So that's the difference between trigonal planar and trigonal pyramidal, for example. So we're going to memorize these things, and then we're going to compare them to the electron domains that we already got. And that's going to give us both the names and the angles. We're just going to memorize those. We're going to memorize the names, and we're going to memorize the angles because that's all we need to know. So let's look at the examples that we already saw, but refer back to this table. If you need it, it's in the supplemental from Lecture 1 posted on Blackboard. So now let's look at those examples that we did before, but we'll go back and compare them to the table. So if we look at example 1, we said it had 4 electron domains. So we'll go down here to line 4, and then we're going to go across for the lone pairs. So this has 3 bonds and 1 lone pair. So which one does this look like? Right, if you answered trigonal pyramidal, which should have an AL there, then that's the answer. So this would be trigonal pyramidal. And then going with that, the angle should be less than 109. If you look, all of the atoms with 4 electron domains have an angle of 109 as sort of the basic angle, but then depending on how many lone pairs you have, the lone pairs cause the bonds to get closer together because they're slightly squished. That's because the lone pair takes up more space. So it's less than 109 or even more less than 109. There are actual numbers associated with that, like this one isn't less than 109, it's like 107, and this other one's 105, but I'm not going to make you remember that level of detail. Just as long as you know it's less than or less than 109, that's all I would look for on a quiz or exam. But just know that also I would not count it correct if you just said 109 for example 1, because that's not correct. It has to have the less than symbol. It also wouldn't be correct to say less than 109 because that's a different thing. So you don't have to know the exact number, but you do have to know the relative angles of these things. So that's why I'm making you do that. So now let's use the table again to try to figure out what's the next shape. So for example 2, remember we have 3 electron domains we said. So which one of these does it match? Right, it would be trigonal planar, and that's an angle of what? 120, right? There's no lone pair, so don't put less than. It would just be trigonal planar, angle 120 degrees. So now for numbers 3 and 6, in this case it says, let's try to figure out what would be the shape and the angle for each of these molecules. Again, pause the video so that way you have time to think about it, and then you can use the table for now, but you're going to have to memorize those at some point, but just work on it for just a second and then unpause when you're ready. All right, so hopefully these are what you got. So for the H3O+, that should be 4 electron domains with 1 lone pair, so that'd be trigonal pyramidal with an angle of less than 109. For the bottom one, we've got 4 electron domains and no lone pairs around the central atom, so that would be 109 tetrahedral. So let's do one more just to make sure we're 100% clear. So here we'll do a classic example of water. So the Lewis dot structure for water should look like this. So now I want you to try it all on your own. Count the electron domains, then figure out the shape and the angle. Pause the video and see if you can get it. Okay, so hopefully that one wasn't too hard. You should have gotten 4 electron domains. And then now there's 2 lone pairs, so that shape is going to be called bent. That's what we're going to call it in this class. And then the angle should be less than 109. Now, if you notice, in this case, there's 2 different bents. There's bent less than 120 and bent less than 109. So that's how we'll distinguish them. If I just ask you for the shape name, just call them both bent. It's totally fine. Don't have to call one a different name. Just keep them the same. Then if it's the angle I want, then you'll want to say either the 120 or the 109 is the base, and you'll put however many less than symbols you need. So make sure you do that. And with that, we are concluding this video. Hopefully you enjoyed this review of Lewis dot structures. It gave you some more detail if you needed it and clarity, but if not, of course you can always ask me questions via email or via Teams for the online course. For this semester in fall 2020, we're just going to talk about formal charge in lecture, so there's no more videos for today. But if it's not fall 2020, make sure you check the course website to see if there's any more videos for today. Thank you.